The next third speaker, Martin Mayfield, Chartered Engineer and Chair of Engineering Design at University of Sheffield. Previously Director for Arup and led on sustainable building, working with clients internationally and in the UK. So, would you like to go ahead? Thanks very much. I think someone's keeping time as well, is that right?
Right, good evening everybody. I've got quite a lot of graphs and one equation. So let's go from there. So this is an engineering perspective which will be a little bit different. And before I do start, one thing that engineers want to champion in life is an evidence-based approach. So you get a lot of anecdote-based advice given to you. And this is an example of a graph that shows the relationship between climate change and the number of pirates in the world. So at the moment, pirates are dropping, although they've now flatlined, and you'll also be hearing in the press that atmospheric temperatures have leveled out as well. So there's clearly a correlation between the number of pirates in the world and climate change. So if you see any of the graphs I put up tonight and you don't like them, please shout out pirate, and I'll come and speak to you afterwards. So this is what I'm going to go through quite quickly, actually, some of this. So the first thing is reading the tea leaves. You know, where's the planet going? So I'm going to go through resource depletion, climate change, and a bit on geopolitics, although I'm not a politician. So in resource terms, we all know this sort of graph. Our consumption of energy as a society has absolutely exploded, particularly in the last 50 years. This is because we used to live like this not so long ago. Around 1900, we moved into cities. We became an industrialized nation. So this is the River Rouge plant in the US, where raw materials come in one end. We have a factory, and cars or bits of cars come out the other. So our demand upon resources accelerated over a very short period of time. This led to that. Oh, the top of the thing's missing. That's interesting. Okay, top of my slide's missing. So this led to mass urbanization. So as people were dragged into cities in order to work in the factories. This has accelerated over time. So this urbanization has further driven economic activity beyond that industrial revolution. And this economic growth has driven energy consumption. So you can see here, along the bottom, we've got energy consumption for countries, and we've got per capita GDP. So there's a clear relationship between those countries that consume a lot of energy and those that have a high GDP, very high correlation along that line. And this, of course, is driving our ecological footprint. So we're consuming resources at a rate about 50% greater than the planet's ability to replenish them. So we're running on 1.5 planets at the moment. And what this means is we're consuming huge amounts of energy. And the challenge for us in this country is kind of represented in this graph. So down in the bottom corner, the EU 27 is us. So our population is growing very slowly, and our energy consumption per person is not growing at all. Whereas pretty much the rest of the world is accelerating away from us, because this is growth rates. So China particularly, obviously, India's beginning to catch up, starting to get its act together, if you can call it that. And over the next 100 years, we can start to see bits of Africa doing the same. Now, our ability to buy energy or food or any raw materials globally will work as a function of the distance between these bubbles and the relative scale of them. So we need to learn how to decouple ourselves from some of these issues, particularly energy. A bit about climate change. It's accelerating. Obviously, our CO2 emissions, certainly in the last 10 to 15 years, have started to pick up. We really started to get a thirst for it. And the real challenge, the real problem, so we all hear about reducing emissions by 80% by 2050. The real issue is the area under the graph, not the end number specifically on its own. So in order to limit ourselves to about 2 degrees of warming, we can't emit more than about 700, so it's 565 there, but between 600 and 700 billion tonnes of CO2 in order to probably hit 2 degrees of warming. At the moment, the fossil fuel reserves of the oil and gas companies, excluding unconventional reserves like that they get from fracking, is about 5 times that. So, and that is worth $27 trillion. Some put it at much. There are numbers up to $100 trillion for the value of it, and that is the value of these companies on the stock market. So we either let all that CO2 into the atmosphere, or we let those companies go bust, which is going to have an impact which is greater than the current crash we've just gone through. So unless carbon capture and storage sets off on a massive scale, which, you know, and it still hasn't been proven at any scale, this is the challenge. Go bust, save the planet. And this is the equation. So this is called the Kea identity, which relates all this together. So at the top we have global CO2 emissions are a function of global population multiplied by GDP per head, multiplied by the energy per unit of GDP, multiplied by the CO2 per unit of energy. Okay, so it's quite a straightforward equation. I won't be testing anybody on it later, and you can see there's a clear relationship and how it all adds up. So this is produced by a Japanese academic, and it's used in order to demonstrate these relationships. So, as engineers, we can't do a lot about global population. So our role as engineers, other than not having children ourselves, we can't do a lot about GDP per head. You know, it's not some other than, you know, trying to decouple prosperity from growth and persuading people they can be happy without money. So the role of engineers, this is what keeps us up at night, is how do we make the world more efficient? So energy use per unit of GDP is the energy efficiency of our economy. So how do we use less energy? And then CO2 per unit of energy is how do we produce energy from renewables. So we're working furiously on the bottom, while everybody else seems to be going the other direction with the top two. So how are we actually doing? So this is from the latest UN report on climate change. So you can see the top one on the left. Population is just expected to keep climbing. GDP per capita, some of the projections are exponential. Energy intensity of GDP is actually doing quite well. It's dropping over time. So we are becoming more efficient as a society. But the CO2 intensity of our energy is pretty much flatlining. And if you were to project that graph back for the last sort of 50, 60 years beyond that to the left, it would keep flatlining. Because every time somebody builds a wind farm, somebody else builds a coal-fired power station. So geopolitics, this is the bit is not really my ground. But anyway, climate change and geopolitics. So the American Department of Defense have said that climate change is the most important, the biggest risk to the US. And I read the very thick report, and it went on into great detail about the potential mega droughts and widespread famine, and how this might lead to massive population migration, particularly in parts of the world which have a nuclear capability, as obviously food won't grow in certain places, so they move. So this could lead to nuclear exchange in some parts of the world. So the conclusion of the report was the American Department of Defense need more bombs because there might be more wars because of climate change. We're now entering what David King calls a period of resource wars. So all the wars and conflicts over the last few years, many of them, not all of them, have been related to resources. We obviously Kuwait and Iraq we know all about, but now we're having a lot of these sort of softer conflicts where people are sort of nudging at the edges. Quite a lot going on in the Arctic, and around Africa and around the Pacific Rim, you know, South China Sea. People actually positioning for resources because they can see what's coming. And again, the US are currently pursuing energy independence by 2035. They've got bills in place. Every state has to produce a percentage of its own energy. That's going to be cranked up over time. The reason they're doing this is not just because it will mean that they're geopolitically free from certain parts of the world that they currently have to have an interest in, but they've calculated that it will double their GDP growth. They spend half of GDP on importing fossil fuels, and they reckon that they can go from 2% to 4% growth by not doing this. That will have a big impact on the rest of the world. And a little bit closer, Boris is copying them. So Boris is pursuing 25, he's promised 25%, London will generate 25% of its own energy by 2025. He set up an energy company to do it. He's trying to push out the big six from various parts of London, well, not push them out, but compete with them to generate some of their own energy, because he knows that he needs to decouple himself from this global energy race in order to maintain London's position. So what might this deliver? We talk about a move from the west to the east. There's lots of reports saying it's a rebalancing. I like to think of it as a shift. 1,000 years ago, the global society was kind of around the Mediterranean. 2,000 years ago, maybe. In the last century, it's certainly been around North Atlantic, where all the power has been, and now we're moving to the Pacific Rim again. So it's not about a move just to the east, it's a move to that Pacific Rim. And that's the thing we've got to think about as a country. And what does that mean for us in the UK and indeed where our grandchildren will live? So what future? So I've talked about the planet. What we're trying to find really is a balance between the two. So along the bottom is planetary health, up the side human development. And of course what we want is what's good for the planet and good for people. We don't want to end up in any of the other little boxes. So that's often called the ecological age. We want to pursue an ecological age. So how might this vary globally? Now, I was lucky enough to spend some time a few years ago pottering around the planet, asking people, well, not just, well, I was backpacking actually, but I was also asking them what they felt about climate change and whether it affected them. And the kind of extremes were really a function of societal complexity and infrastructure complexity as well, actually. So in Japan, they were a bit hacked off because they booked all their holidays in order to go and take photos of the blossoming in spring, and they had to change the holidays because it was blossoming a bit earlier. In Nepal, they were getting one less crop cycle a year, so they went from 4 to 3 or 3 to 2 crop cycles, which meant that the crops they would sell to then provide for their children and their children's education, they meant they didn't have enough money. So the thing that got cut off was children's education. So the impact of climate change, I'd suggest, and there is quite a bit of evidence around this, is directly correlated to the vulnerability and complexity of those societies. And right. Just moving that on a little, there's a reinforcing feedback loop. So that's a reinforcing feedback loop, that those are most vulnerable and most at risk. What we're also doing is we're densifying our cities, and we're densifying some of them in the wrong place. I'm going to come on to that. But what we're finding is that the seas might be rising a little, but we're actually, as we densify in some of these places, the cities are dropping quicker than the sea's rising. So, and in some parts of the world, 10 times the difference. Tokyo dropped 2 meters before they, over quite a period of time, before they realized that because of a groundwater extraction and development, that there was a bit of a problem. So you can argue that we've got to be careful. These are all near the sea, obviously. We don't really want to be building too close to the sea, do we? Anyway, half the world's population live inside that circle. This is where 7 out of the 9 largest river basins on the planet are, and they're all under massive development. So most of the development in the world, a large proportion of development, well over half of the urban development in the world, is in the river basins of the most problematic areas. So as a society, we're not making very good decisions at the moment. I want to talk a little bit about how our societies also handle technology. So you might have heard of the diffusion of innovation. Now, the diffusion of innovation is the rate at which a technology generally or anything diffuses through society. So from the early adopters who buy the iPhone the day they come out to the laggards who buy them eventually because there's nothing else on the market. Now, the rate at which a society adopts technology affects its ability to innovate. So you get the USA, they're quite tight, they're quite good at adapting and adopting technology, and you get kind of French at the other end saying, well, we don't want any of that technology rubbish. So the diffusion of innovation is really important to a society in terms of its resilience in the face of various matters, not least disruptive technology. So we get disruptive technology come along, some see it as a negative thing, some see it as a good thing. So as we get more and more, and disruptive technology is accelerating. I've got more graphs on that which I won't show you, but so the amount of disruptive technology and the impact on society, and particularly economy, is accelerating. So a society's ability to deal with that is a function of how tight that is. So we as a society need to make sure we're good at understanding technology, grabbing it for our uses, and moving forward. Being careful, but not just grabbing everything. But it's a key issue in terms of the resilience of a society. So what might this mean? So that little graph, remember on the right-hand side, planetary health, human development index. We're aiming for that top corner. Now this is the same graph, but the bottom axis is flipped around. So it's ecological footprint. So we want a low ecological footprint. And then up the side, it's human development index. Now, human development index is often sort of cheekily called how Scandinavian you are. It's a measure of life expectancy, happiness, education levels, and income, so on. So our aim really is to get the whole planet into that blue box. Now, when I first saw this graph in 2008, the ecological footprint of everybody, this is how much land it takes to keep you fed and the energy and so forth, was 2.2 hectares per person. It's now 1.7 hectares per person because there's more of us. So the challenge is to get all the developed countries to reduce their ecological footprint and all the developing countries to maintain their ecological footprint more or less, but to raise the quality of life through improving healthcare and education and so on and so forth. So that's the ecological age as an engineer sees it. So in terms of those planetary boundaries, what do we mean by ecological footprint and planetary? So there's a nice definition for what we mean by environmental sustainability. There's 9 planetary boundaries. I'm not going to go through all of them, but it's all the kind of usual suspects, which is kind of our impact on the planet. And there's pretty much consensus that if we can manage these impacts on the planet, we'll be okay. Now, bear with me. There is a bit about housing at the end of this. So if you think of those, there are the planetary boundaries on the left-hand side. So what should we do? Well, we need to reduce our emissions for climate change and acidification. For ozone depletion, we need to stop using HCFCs, etc. Land use, we need to inhibit the conversion of land use for human usage. They aren't my words. Chemical pollution, we need to limit, obviously, pollution. Human interference with the nitrogen cycle, highly regulated and efficient farming, aerosol loading, inhibit land conversion. So we basically need to get out of the way as far as the planet's concerned. So what that means is we need to urbanise the whole of humanity. We need to create compact, connected cities, again, not my words, in order to be efficient in how we deal with resources, to recycle, to reuse. All of this works better in pure physics if things are closer together. So we essentially need to get into cities. And compact, just a few more graphs on compact. There's lots of work being done on the relationship between population density and CO2 emissions for cities. Chris Kennedy's work's probably the best of it. The energy metabolism, the urban metabolism of cities. Cities are much more sustainable if they're compact. There's lots of work being done on the scale of cities. And the bigger the city are, the more economically successful it is. There's a clear correlation there. I mean, crime also goes up as well. But this is a study of US cities by Santa Fe Institute. It's a clear relationship between scale of city and economic development. So you want a smaller number of larger cities economically is what that suggests. There's a clear indication of a relationship between total costs broken down by housing and by transport. So if we can design our cities so that we don't have to travel so far, it will keep people's total cost down. And of course, commuting times. There's a clear correlation between how far people have to travel to work generally and what their life satisfaction levels are. So we don't want to travel too far. We don't want to commute too far in cost terms. In carbon and energy terms, it's a bit of a no-brainer, and it seems to be economically. So compact cities seem to be the right thing to do. Connected. So we obviously, we want them to be connected. We want them to be internally connected. So a little graph in the top left-hand corner shows how various ways of connecting cities internally has accelerated massively, particularly since the year 2000. So a lot of that's around the kind of smart agenda and people, having more data about what's available in their city that allows them to do car sharing, bike sharing, smart cards and so on. So we're getting better at being connected in cities. And then apps like Uber and Lyft and so on that allow you to short-circuit some of the current systems in order to get a lift from somewhere to somewhere else. You don't need a car anymore in a lot of cities. So that's sort of internal connectivity. Externally, One North, obviously, from a Sheffield context, all the arguments around a northern powerhouse make a lot of sense, so we need to be connected as well as compact. And of course, everybody talks about high speed too. So we have dense, well-connected cities. So how are we going to get there? This is the ecological age. Wonderful. It's one big complex system. So everything is connected to everything else. We know all this. So population levels, human social capital, financial capital, etc. So I'm not expecting you to read that. It is all one connected system. We can't see this as a set of separate issues. Now, luckily, we have systems theory and we have systems engineering. So on the left is the 12 points of leverage in a system. And the more you go down that list, the more the impact is. So most of the time in society, in policy work, we end up fanning around with number 12, numbers. We want a 5% improvement, we want a 10% improvement. The real opportunities as you get further down this, you start to improve your feedback loops, you start to improve your information flows, you play with the rules, you promote self-organisation, you focus on goals. Goals are really important, and what's really important are the people that define those goals. So we have GVA as a goal, and we have GVA as a goal because we measure it. We don't have resource depletion as a goal because we can't measure it as well, and it doesn't really relate to GVA. So we need to move to a position where we have a much better systemic understanding of how these things relate. And what we really want is to be able to sort of transcend those paradigms. We don't just want to have a focus on GVA or resource depletion. We want to be able to do all of them. And what inhibits us from doing that is something called bounded rationality. Now, we all suffer from it. We make what we think are totally rational decisions, when if you got the chance to step back and look at it, you think, well, why would I do that? You know, I'm a big believer that we've got to make big challenges, and we need to, you know, but I still got on a plane and took my kids on holiday last year. So we all suffer from bounded rationality. Sorry, here's the second equation. I forgot there was two. So our ability to make decisions is a function of these three facts. The information that we have in order to make that decision, our cognitive limitations, be that temporary or permanent, and the amount of time we have to make a decision. So if we want to make better decisions, we need to release, you know, unplug some of these issues as a city. So just an example of that. So we've probably all heard of Adam Smith's book, Wealth of Nations, which, you know, every economist has read. It's a huge tome. I didn't get through it. So our economic system, our capitalist system, is based upon Adam Smith's book. Not many people have read the other book. I've started it. So this is his less famous book, which argued that we need a close-knit society that works hand in hand with that capitalist environment in order to get the right outcomes for society. So this is transcending paradigms. This is a systemic approach. This is what we need as a society. So I've said, you know, making good decisions is the most important commodity that we can make, a city can make. So this question about whether we should be greenfield or whether we should be brownfield is incredibly important, and we're doing it without data. We're doing it without the instruments to make the right decisions. We're doing it without the right tools, but most importantly, we're doing it without the data. And if we had that data, we'd be in a much better position to make those decisions. So, a little pop quiz. So you've got £1 billion to invest on your city. Do you spend it on High Speed 2, or do you spend it on One North? £1 billion, quite a lot of money, really. So how do you spend it on either? Well, everybody's thinking about High Speed 2 at the moment, but last week, Jim O'Neill, who was the ex-chief financial advisor to the vampire squid Goldman Sachs and has just led the city's commission on growth, has said that just in the last week. That obviously One North is much more important than High Speed 2. That raises a question, doesn't it? So your £1 billion, do you spend it on that energy independence? You know, there is evidence that by decarbonising and decoupling your energy supply as a city, it leads to growth. That's Stockholm's figures that show that as one's happened, the others happen. Yeah, correlation, I know, you know, I accept that's not necessary causation, but it has allowed them to reduce their energy costs. And Boris is, as I said, doing the same thing. And as I've said, the US are targeting that. So you've got your £1 billion. So which is better spent? Which is going to increase GVA the most? Or is it teaching? You know, there's a clear correlation between GDP per capita in most of the OECD countries and that expenditure on primary and secondary school. So why not take the money that you're about to spend on that infrastructure and spend it on teaching? And that will actually economically improve you a lot more than the other. We don't really have the data to do it. So if it's which country, I think my answer really is if the UK can limit or manage population growth whilst maintaining some diversity and allow us to decouple economic growth from prosperity, create those compact connected cities I talked about, and decouple the energy supply, then it might be a good place to live. And of course, within that country, where would you live? It's pretty obvious, really. You'd live in Sheffield. So that's it. Thank you very much.